Hey there, AI enthusiasts. Today, I'm diving into how the McGinty Equation, or MEQ, is transforming AI into something almost self-aware. First up, let's talk fractal geometry. The MEQ includes a component called piece fractal XTDMQS that introduces self-similarity across different scales. What does this mean for AI? Well, traditional AI relies on hierarchical models for processing information. But with fractal geometry, AI can recognize patterns within patterns, just like natural structures do. Imagine an AI in healthcare. It could zoom in on individual cells and simultaneously consider the larger systems within the body. This multi-layered approach could help diagnose diseases by revealing hidden patterns that traditional models might miss. Essentially, AI becomes better at handling complex, multidimensional problems, opening doors in fields like genomics and financial forecasting. Next, we've got quantum field corrections, or PES-QFT-XT. This part of MEQ allows AI to incorporate principles from quantum field theory. What's the big deal? It means AI can handle uncertainty and probabilities, exploring multiple outcomes simultaneously. This probabilistic approach boosts AI's adaptability and problem-solving skills. Think about autonomous vehicles. With quantum field corrections, an AI could process sensor data in real time, adapting its decisions based on new information. This makes AI more resilient and capable of making complex real-world decisions, even in unpredictable situations. Now, let's talk about self-organization and emergent behavior. The MEQ helps AI systems develop hierarchies of knowledge that self-organize over time. This means they can learn and adapt without human intervention. In robotics, for example, self-organizing AI could lead to machines that adjust their movements based on experience. This could revolutionize manufacturing by enhancing efficiency and quality on the fly. Integrating the McGinty equation into AI isn't just an upgrade, it's a leap toward cognitive evolution. MEQ-powered AI systems can solve problems on multiple levels, adapt to changing inputs, and autonomously develop new knowledge. Imagine AI in creative industries generating art, music, or literature that evolves over time. Or in scientific research, identifying novel compounds based on fractal patterns in molecular interactions. For AI developers and researchers, the McGinty equation offers a new toolkit for building more flexible, resilient, and self-aware systems. By applying fractal geometry, you can uncover patterns that traditional algorithms miss. Through quantum field corrections, you can boost AI's adaptability and problem-solving skills. As AI evolves with the McGinty equation, it has the potential to become a partner in innovation, creativity, and discovery. This next generation of AI won't just process data, it will interpret it, learn from it, and contribute to our understanding of the world in profound new ways. We're on the brink of a cognitive evolution that could redefine intelligence itself. Thanks for tuning in. If you're excited about the future of AI, don't forget to like, share, and subscribe for more fascinating insights. See you next time. See you next.